Both the ocean and sea are large or vast waters that covers for about 70% of the Earth's surface. It provides us with food, life, entertainment, jobs, and also sailing. Without it, we cannot survive. However, the sea itself has actually took many lives that caused by rip tides or rip currents. And every year, more than 100 beachgoers on average drown due to these strong river-like channels of water that pull swimmers away from the shore, according to the US Life Saving Association. Have you wondered how did this happen? And did you recognize at the entrance of most beaches there is a bulletin board with notice about water conditions, maybe a faded sign warning about rip currents, or a list of these weak tides? Most of people passing them by without a second thought. But if you want to enter the ocean, it is important for you to know its movement, to avoid being caught by a rip current, or to figure out when the waves will be at their best, or in other words, whether you are safe to enter the ocean. A horizontal movement of water is often accompanied by the rising and falling of the tide. This is called the tidal current. The incoming tide along the current and into the base is called a flood or flow current, while the outgoing tide is called an ebb current. The questions are how this is happening and what method to measure these ebb and flow tides, and what are the contributions that we can get from this phenomena. Keep watching because that will be clearly explained right after this.
Do you know that both of moon and sun influence the ocean tides? The moon plays the biggest role because it is so much closer to our planet than the sun. In fact, the tidal effect of the moon on Earth is more twice as strong as the sun, even though the sun's gravitational pull to Earth is around 178 times stronger than the moon. So now, have you wondered what is tide and what causes the tides? Tides are the periodic rise and fall of the sea level at a particular place. When the sea level rises at its greatest height, it is known as a high tides. When the sea level drops to its lowest height, then it is called as a low tides. So tides are primarily caused due to the gravitational force of the moon. But how? Part of the Earth that are facing the moon is experiencing a strong gravitational pull toward the moon compared to the Earth's center, and it will cause a bulge on the Earth's surface that are facing to the moon. So that part will experiencing the high tides. Then the Earth's center will also experiencing a gravitational force toward the moon. Then the part that are facing opposite to the moon will also create a bulge, hence will also have a high tides. The place between two high tides where the sea level drop is experiencing the low tides.
On Surah Yasin verse 39, and the moon we have determined its phases until it return appear like the old dead stalk. In that ayah, it stated that the moon have its phases and all of that is depend on how much you can see facing the sun, because the sun's light reflect off the moon and enabling you to see the moon's shape. When the moon is full or new, the gravitational pull of the moon and sun are combined. At this time, the high tides are very high and the low tides are very low. This is also known as a spring high tides.
Wait a minute, do you know how can the ocean had tide but lake, bathtubs and coffee don't? Nevertheless, those bulges in ocean are real. The ocean isn't being stretched, but then how tides happen? The key is to look at the tidal acceleration of objects that are not on the Earth or moon line. For instance, a block at this location is going to be pulled this way by the moon. Of course, the whole Earth is pulled away by the moon, chasing after the block. Relative to the Earth's surface, the block's tidal acceleration is almost radially inward, in other words, down. In fact, if we map out the tidal acceleration vectors that you will see at different points on Earth's surface, they look like this. As you can see, the tidal forces only act like anti-gravity if you are right on the at most places, which will push water sideways. Now, we have drawn these vectors kind of big to help you visualize them. But in reality, they are microscopic. Radially inward acceleration caused by the Earth's own gravity on objects is 10 million times bigger. However, the surface area of the ocean is also enormous, so those tiny tangential, it then added up over half the surface sideways pushes on all the chunks of water of the planet that can produce a pretty decent increase in water pressure. In conclusion, the ocean isn't being lifted or stretched. Instead, it is being squeezed towards the Earth or moon line and peeling up there. Basically, the moon is turning the entire ocean into a planet-sized hydraulic pump, and the ocean is bulging along the Earth or the moon line.
The method that is used to measure the ebb and flow of tide is hydrographic data measurement. Lower acoustic Doppler current profiler (LADCP) is the tool that is used in this measurement. Lower acoustic Doppler current profiler (LADCP) can measure the depth, speed, and direction of the water current. This will give us better understanding about ebb and flow and the effect of it. However, the frequency of the acoustic wave used is high that even human and even dolphin cannot hear it. To measure the depth of the ocean, LADCP emits an acoustic wave and measure the time interval for that acoustic wave to come back to calculate the depth. To measure the direction of the water current, LADCP emits acoustic wave to the ocean and then measure the frequency of the reflected acoustic wave. If the reflected acoustic wave have higher frequency than the emitted acoustic wave, the water current are moving toward the LADCP. If the reflected acoustic wave have lower frequency than the emitted acoustic wave, the water current are moving away from the LADCP. This phenomena is called Doppler shift. By measuring the time interval for the wave to come back and the Doppler shift, LADCP can determine the water current speed at many different depths of the ocean. So, we have understand how LADCP work. But how to use the LADCP? From a ship or a cruise, ADCP are lowered by wires for some distances above seabed and raised back to the surface. Additional constraint on the LADCP must be removed. Example of additional constraint is ship drift. Ship drift is the involuntary movement of the ship due to water current movement. The LADCP that attached to the ship will also be moved. This involuntary movement must be taken into the account to avoid error in calculation of direction and velocity of the water.
However, the method used is called hydrographic data measurement. The collected data later will be processed, analyzed, visualized to form tide tables in quite complicated way. In the present years, it has been simplified to ease most of us, especially fishermen, surfers, or whoever is taking vacation to the beach area. But how to read a tide chart? Now, let's get started. First, you may find any online tide table with a simple search, for example, tidechart.com. Then search specific area that you plan to visit, for example, Port Dickson in Negeri Sembilan. The chart will come out with the present date. Look at the y-axis show how high the tide could be, and the x-axis show time in 24-hour clock. To make sure you know to differentiate between morning and night, the light area here indicates daylight and dark indicates night. The graph shows two high tides and two low tides in a day. The highest tide is shown at 12:13 p.m. of 1.83 meters, while the lowest tide of 0.37 meters was at 7:21 p.m. If you plan to have a vacation on the same week, you may refer to the tide activity here, then locate the date. Note that as high and low tide time will be different every day, therefore you cannot make a future plan based on a chart at present. So this tide chart could help you guys. For those who love fishing, you may refer to these tables. It presents you the suggested time for fishing activity based on the collected data of the tides. Each column helps you in predicting a better That's all. Thank you.
Contribution of ocean tides. By understanding ocean tides, human can gain many advantages. It can be said form of ocean contribution to human society. One of it is vessels docking. All types of seafaring vessels are also greatly affected by the tide. and for centuries crew and captains alike have had to study the tide change. Many boats, for instance, dock at port during high tide, but move too far up toward the shore so that at low tide the vessel is stranded. If the vessel is on a schedule and need to leave, then the crew must haul it out to deeper water so it can take float again. So not only do tide affect the coming and going of ships, but also the construction of the dock themselves and what dock can be used when. In an especially low or neap tide, many ships can be stranded in the mud. Scientists are able to predict even this drastic tide change with great accuracy. Ship cost to the port greatly related to tide change.